Welcome everyone. In this video, we will delve into the fascinating world of linked lists. Linked lists are fundamental data structures in computer science offering dynamic ways to organize and manage data. Today, we will explore various operations on linked lists from inserting and deleting nodes to traversing the list to access and display the data. By the end of this video, you will have solid understanding of how linked lists work and how to implement them in Python. We will cover everything from creating a linked list from scratch to performing key operations such as inserting and deleting nodes. Whether you are new to Python or looking to deepen your understanding of data structures, this video is for you. So let's dive in and explore the world of linked list in Python. The topic we are going to discuss here is about linked list. A linked list in Python is a data structure that consists of nodes where each node contains a value and a reference to the next node in a sequence. It's a linear collection of elements, but unlike arrays, the elements are not stored in contiguous memory locations. Instead, each element points to the next one, forming a chain-like structure. The flexibility allows for efficient insertion and deletion operations, but accessing elements by index can be less efficient compared to arrays. So the task we are going to do here is to create a Python program to solve these functions. So at first we have to know how to create a linked list. So in this video we will learn how to create a linked list. Then insert of operations like a function to insert at the beginning of a linked list, at the mid end of a linked list, and also at the how to insert a node at the middle of the linked list, and same as how to delete a, a node in the linked list. So to create a function to delete a node at the end beginning of the linked list, at the end of the linked list, and to delete a node at the middle of the linked list. So also we will know how to traverse the linked list. That means to create a function to display all data stored in the linked list. So without wasting much time, let's move on to the code, and also we will understand the logic by coding itself. So let's dive in. In the coding part, we will start by creating a class named node, and at first a function to create a node. So double underscore init will be the name of the function, and in bracket we will give self and data, self comma data. Then self dot data is equal to data, and self dot next equal to none. This block of code defines a node class. Each node will hold a piece of data and reference to the next node in the linked list. The double underscore init double underscore method initialize a node with the given data and set the next reference to the node. Then comes another class named linked list. Class linked list. Here at same I am going to create a function named init double underscore init double underscore in bracket I am giving self, and self dot head equal to none equal to none. So this block of code defines a linked list class. Each linked list will have a head attribute that points to the floor node in the list. Initially, it is set to none, indicating an empty list. So we have learned how to create a em- empty linked list. So next, we have to know how to insert values into the linked list. So the first condition to insert is the question reminds us that we have to first create a function to insert at the beginning of the linked list. So to insert at the beginning of the linked list, we'll create a function named insert at beginning, insert underscore at beginning. In bracket, I will give self, comma data. So new node, new underscore node equivalent to node of data, node of data, new underscore node dot next equals to self dot head, then self dot head equals to new underscore node. This method inserts a new node with the given data at the beginning of the linked list. It creates a new node and set its next reference to the current head of the list and then updates the head to the point to the new node. So it's just confusing a code, but you will understand it better. The insert at end. This is the next condition that we have to insert at the end of the linked list. So the insert underscore at end in bracket self comma data. Here we have to create new node, new underscore node equals to node for data. Then if not self dot head, if not self dot head, self dot head, self dot head equals to no underscore node. Then return current equals to self dot head. While current dot next, while current dot next, current is equals to current dot next. Current dot next equals to new node. Current dot next equals to new underscore node. So this method inserts a new node with the given data at the end of the linked list. If the list is empty, it simply sets the head to the new node. Otherwise, it traverses the list until it reaches the last node and then appends the new node to the end. So in this if not self dot head, this line of code checks whether the linked list is empty. If it is empty, then the new node will be appended to the end cell head of the cell. Otherwise, it will traverse the list until it reaches the last node and then appends the new node to the end. Then the next condition we are going to create a function with is to create insert a value at the middle of the linked list. So insert underscore at middle my t2 in bracket self comma data. So if not previous prep underscore node, then previous previous node is now in the list, not in the list. Return. Then new underscore node equals to node of data. Then new underscore node dot next equals to pro underscore node dot next. Pro underscore node dot next equals to new underscore node. So the error here is I have not mentioned prev node on this. So here along after self we have to mention prev underscore node and then data. So it will clear the error that was there previous. So this method inserts a new node with the given data after a specified previous node in the linked list. If the previous node is not found, it prints a message and returns. Otherwise, it inserts the new node between the previous node and its new node. So the functions that can be used to insert are created here. Then we will move on to learn how to delete a node from the linked list. So same as inserting, we have to first create a function to delete from the beginning of a linked list. So def delete underscore beginning in bracket we have to mention self. Then if node self dot head print list is empty, nothing to delete. Sorry, list is empty, nothing to delete. It basically check whether the given linked list is empty. If it is empty, we cannot delete anything from the linked list. So we first check whether the linked list is empty or not. If it is empty, we will print a message there. Otherwise, we'll move forward with the program. Self dot head is equals to self dot head dot next. This method deletes the node at the beginning of the linked list. If the list is empty, it prints a message and returns. Otherwise, it updates the head to the point to the next node, effectively removing the first node. Let's just overwrite it. Then the next condition we are going to follow here is to delete from the beginning. So to delete underscore end in bracket, we have to mention self and if not self dot head self dot head print list is empty, nothing to delete. Print list is empty, nothing to delete. Then we have to return it, of course. We have to return. Then, if it will check whether the s- uh, linked list is empty or not, we know that. Then, if it is not empty, it will continue with the program. Like it will, if not self dot head, if not self dot head dot next self dot head is equals to self dot head equals to none. So now we have to delete a node from the middle of the linked list. So to create function def delete underscore middle bracket and in self comma e with no self dot head print list is empty. List is empty. Nothing didn't. And we will return this. If the linked list is not empty, we will continue with the program. Like if self dot head dot data equal to e self dot head equals to self dot head dot next. Return then rel equals to not current equals to self dot head while current and current dot data current dot data not equals to e rel equivalent to current current equals to current dot next. If not current, if not current, print key not found in the list. Print key not found in the list. It will return and then print print dot next equal to current dot next. This method deletes the node with the specified data from the linked list. If the list is empty, it prints a message and returns. If the node to be deleted is the head, it updates the head to the point to the next node. Otherwise, it traverses the list to find the node with the specified data. Updates the previous node's next reference to skip over the node to be deleted. It's a lengthier one. It takes time to understand. Now, let's once again go through the program. First, yeah, at first it checks whether the list is empty or not, linked list is empty or not. If it is empty, it will return a message. Otherwise, it will move through the program. It if the node to be deleted is the head, it updates the head to the point to the next node. Otherwise, it traverses the list to find the node with the specified data. updates the previous node's next reference to skip over the node to be deleted. So the next function I am going to create here will be to display the linked list, the display from cell current equals to cell dot head while current print current dot data comma n equals to and equals to that current equals to current dot next print. Now, this method displays all the data stored in the linked list by traversing the list from the head to the last node and printing each node's data. It ends the display with a none to indicate the end of the list. So to work this program, I have to uh, call the linked list. I have to assign the class linked list to link underscore list equals to link list link list. Then I am going to insert some values at the beginning, at the end, and at the middle of the list. So link underscore list dot insert at the beginning of one. I'm giving one to insert in the beginning. Then at the end, I'm going to insert three at the middle, insert at the middle. In bracket, I am giving linked list dot head, linked list dot head, comma, two. And now I'm going to print the initial state of the linked list and initial linked list and link calling the function display to display all the elements in the linked list. And I'm going to now execute the delete functions to delete from the beginning. And first linked list dot delete beginning function like that. And after that I'm going to print linked list after linked list after deleting node from beginning. So this level function, right? So then I'm going to delete it from the end. Take this dot delete from end function bracket. Then I'm going to print list list after deleting no from the end. List of the then I will delete the to will then list after deleting the middle element. Then was after deleting so display it will display the labels. Now I'm just going to run this program. Now let's just run this program. So at the initial stage of the linked list, we get one, two, three, and none. We have inserted one, two, three, and then none. When the inserted elements are nodes are finished, it will provide a none one. When we delete from the beginning, the one get deleted and two, three will be displayed. And at the same, when we delete it from the end, three will be deleted and only two will be remain. And from the middle element, the two will be deleted and at last the none will be rendered. So I hope you understand this program. Thank you for watching this video. I hope you understand this topic really well. See you in next one.